Hello students, today's agenda is to check homework. We'll be learning polynomial identities and you will be able to do 3.8. Today students will be able to prove polynomial identities. And we have done identities before with complex numbers, but this time will be with polynomial. However, we're going to start with a warm-up just to make a connection. And so it says in here multiply. So x times x is x squared. X times negative 10 is negative 10x. 10 times x is 10x. And 10 times negative 10 is negative 100. We combine like terms, and as you can see, the middle two terms for outside and inside of FOIL cancel each other, and so you end up with x squared minus 100. If you had noticed, it's x plus 10, x minus 10, so it's almost identical. However, there's a tiny difference. One is positive, one is negative. For the next one, you can use the Pascal triangle or binomial expansion, or you can just multiply. So just bring down and then a plus b times a plus b times a plus b. From the first lessons, you can just remember that for perfect squares, if we take this 2, it's just square of the first one plus 2 times a times b plus b squared. And that will be taking care of those two. I multiply by this one. And you can just do it in any order. You can do the multiplication of 3 first or this first. And I think I'll just do it this way, the double distributive property, to make our lives easier. So a times a squared is a cubed. A times 2ab is 2a squared b, and a times b squared is ab squared. Then the second one, and that's why I call it double distributive property. And so b times a squared is, if you put it in alphabetical order, is a squared b. 2 times a b times b is 2ab squared, and then b times b squared is b cubed. We still need to multiply by that 3, but I think it's easier as well if you combine like terms first. And I notice that I have here a squared and b, and I have here a squared and b. I also have ab squared, and so I bring down the 3, a cubed, I combine this, and 2 plus 1 is 3a squared b. And for this one, 1 and 2 is 3ab squared. And I bring down the b squared. Finally, and it's barely going to fit, I multiply the 3 times every single term in here, and the final answer will be 3a cubed plus 3 times 3 is 9a squared b. 3 times 3 is 9ab squared, and 3 times b squared is 3b squared. So that's my final answer. Okay, for the last one in the warm-up, I noticed that these are again factors of a difference of squares, so I know that it's going to be x squared minus q squared. And I multiply by 4, use distributive property, and I get 4x squared negative 4q squared. Okay, and that'll be the answer here. And so for each one of these ones, what it's saying is that we can create an identity by putting this equals whatever they gave us. An identity is something that we put equals in the middle and we know that they're equal to each other. To prove that an identity is true, we can just simplify one of the sides, and then if they're equal at the end, that means that they form an identity. And when they give it to us, that's how it is. Prove the following polynomial identities. And so you can see that there is an equal sign, that you have something on each side. Sometimes you can factor it, but it requires more steps. So the easiest way in this one is to simplify the right side by doing distributive property, double distributive property, because first you multiply the x times each one of the terms, and then you multiply the second term. Okay, so let's begin. The other part, you just keep it the same. So, and it's kind of like, is it equal to? Okay, so x times x squared, that will be x cubed. X times negative xy, it will be negative x squared y. X times y squared, positive xy squared. Now I do the other term, and so positive times positive is positive. Y times x squared is, if I put it in alphabetical order, it's x squared y. Then positive times negative is negative. And y times xy will be xy squared, right? Because the x, we don't have anything else to multiply it with, but y times y is y squared. And then the third one will be positive times positive is positive, and I'm just going to write it right here, or maybe around here. Y times y squared is y cubed. Okay, let me erase this. And so now I can look for like terms. I notice that I have here x squared y is right here as well. I like to use either shapes or colors to make it easier for me. And then I have x and y squared. So I'm using rectangles in this case. And these are just by themselves. So I put x, negative x squared y, and positive x squared y cancel each other. Positive xy squared and negative xy squared, they cancel each other as well. And so you just have plus y cubed. So this again, we just bring it down and we say, yes, it's a true identity, and we just proved it to be true. Why? Because we end up with the same on both sides. Okay, number 2, we're going to do the same thing, and we just multiply the x times each one of these terms. And so x times x to the 4th is x to the 5th. X times x cubed y is x to the 4th y. X times x squared y squared is x cubed y to the 2nd power. X times x y cubed is x squared y cubed. And x times y to the 4th, that's x y to the 4th. Now we do the second distributive property, so negative y times each one of these terms. And again, I want to try to see if I can arrange them with like terms. So I'm going to end up with x to the 4th and y. So I notice that it's like terms with this term. So just negative times positive is negative. And y times x to the 4th is x to the 4th y, by putting it in alphabetical order. Negative times positive is negative. And I, again, will end up with x cubed. And y times y is y squared, so I just put it in here. See, because the x cubed and y times y is y squared. Then for this one, I will end up with y cubed, right? Basically, because of this y, it's just adding one more y. So I'm just going to put it here. Positive times negative is negative. The x stays the same. And y squared times y is y cubed. For the next one, again, this y will end up with to the 4th. And the x is just x. So negative times positive is negative. X and y cubed times y is y to the 4th. And finally, negative times positive is negative. And y to the 4th times y is y to the 5th power. By arranging them in columns, makes my life easier. It does take effort to see where would it be placed, but at the end it pays off. And so in here, x to the fourth y minus x to the fourth times y, they cancel. This is the same. They're opposites of each other, so they cancel. X squared times y cubed, negative x squared times y cubed, they cancel. Positive x times y to the fourth, negative x times y to the fourth, they cancel each other. And what do I end up with? X to the fifth, negative y to the fifth. And these I just bring down, so it's x to the fifth minus y to the fifth. And I notice that they're equal to each other, and so yes, they are a true polynomial identity. And why is that? Because they end up being equal when you simplify one of the two sides. Sometimes you have to simplify both of the sides, but in this case, you only have to simplify one of them. Okay, this was a short lesson. We have gotten to the end of it, but if you can please give us a thumbs up, subscribe around here. This is the link to the entire unit. Here will be the next video. Now you're able to do 3.8 and have fun.